Bismillahirrahmanirrahim. My name is Dr. Imran Wahid and I will be discussing with you a very important topic, that is cardiac action potential. But before we discuss the cardiac action potential, it is very important for you to know that what is a cardiac muscle cell or a cardiac myocyte. You can see in this diagram that a cardiac muscle cell or a cardiac myocyte is a small cell with serrated margins. It has a central nucleus and a cell membrane like other cells. A very important feature of cardiac muscle cells is that these cells are not arranged singly, but they are connected to each other in the form of a specialized arrangement which is known as synthetial arrangement or a syncytium. The reason is that why the cells are connected to each other, that when one cell undergoes an electrical activity or stimulation, it is transmitted to the other cells through gap junctions. These are small perforations or porins in between the cells and known as gap junctions. These are the gaps which allow the activities or movement of ions from one cell into the other cell and to third cell. You can see there are three cells, cardiac muscle cells, cell number 1, 2, 3 and 4. So when an activity takes place in cell number 1, it is transmitted to cell number 2 and cell number 3 and cell number 4, as a result of which when the contraction or any movement takes place, the cells they could contract or behave together in the form of a one unit. You see, heart contracts as a one unit in the form of a chamber, a ventricular muscle or an atrial muscle. So that is why the cells are connected to each other in the form of a syncytial arrangement or interwoven with each other, and are also connected to each other through small openings between the cells. These are known as gap junctions. Gap junctions or intercellular communications. As I mentioned earlier, this arrangement of cells in which cells are interwoven to each other and they are arranged in specialized structure which is known as syncytial arrangement or syncytium. You can see the syncytial arrangement here. This arrangement is important for unit or single as a whole unit contraction of the cardiac muscle cell. These gap junctions are very important. They allow the ionic movements or electrical events to be transmitted from one cell into the other. Due to these gap junctions, when one cell is stimulated, the other cells as well as are also stimulated, due to which cardiac muscle contracts as one unit. That is to say that gap junctions are important, which allow the stimulation of one cell electrically to allow it to stimulate other cells as well, so that it stimulates the other cells, as well as due to which cardiac muscle contract as a whole unit. It means that the wave of electrical activity or depolarization spreads from one cell to all other cells, and as a result of that the cardiac muscle contract as one unit. This is very important to understand this structure before we understand cardiac action potential. Next important point is that, as I mentioned in my previous lecture which I delivered earlier about the movement of ions across the cell or ionic movements, I told you that the cardiac muscle cell, it is electronegative on the inner side. That is, there is negative charge on the inside of the membrane and positive charge on the outer side of the membrane. That is, cell is electronegative on the inner side. Another important point to know is that sodium is the major extracellular cation, while potassium is the major intracellular cation. Under normal resting conditions, the cardiac muscle cells or cardiac myocytes are electronegative on the inner side. You should know this. This is very important and is illustrated in this diagram. Now the question is that what this electronegativity and electropositivity, on the inner side electronegativity, on the outer side electropositivity, what is this known as? This is very important. So question is that what is the resting membrane potential of a cardiac muscle cell or cardiac myocyte? Under resting physiological conditions, this is known as resting membrane potential. Resting membrane potential is the potential or electrical difference across the cell membrane under resting conditions. Basically, it is simply the electrical voltage or potential difference between the inside of the cell membrane and outside of the cell membrane of cardiac myocyte. You can see here, I have clarified in this diagram that there is sodium ion is the major cation extracellular and potassium ion is the major intracellular ion. You see, the cell is positive on the outer side, electropositive on the outer side and electronegative on the inner side. This potential under resting condition is known as resting membrane potential. The normal value of the resting membrane potential of a cardiac muscle cell or myocyte is minus 90 millivolt. Now, The another important point is that as I mentioned you while discussing the physiology of the cell membrane, that there are certain channels. There are peripheral proteins, integral proteins, porins, and different ion channels which allow the movements of ions across the cell. Similarly, I would like to tell you here regarding the cardiac action potential that in cardiac muscle cells there are certain channels which are sensitive to changes in the voltage or electrical current. They are known as voltage gated channels and they are present in the cardiac myocyte membrane. These channels are sensitive to changes in voltage or electric current and they include sodium, calcium and potassium channels. In this diagram, you should see clearly that this is the cell membrane of the cardiac myocyte, this is the nucleus. These are sodium channels, voltage gated sodium channels, these are voltage gated calcium channels, these are voltage gated potassium channels. So these are very important in the generation of the action potential and maintenance of the resting membrane potential and also the repolarization phase we will discuss later. Another important point to know is that what is threshold potential. As I have told you that there is a resting membrane potential which the value of minus 90 millivolt, and what is threshold potential? Threshold potential is the electrical potential at which the membrane of cardiac muscle cell will suddenly open voltage gated or voltage sensitive sodium channels with a rapid influx or inward movement of large number of sodium ions into the cell, that is the sodium ions move rapidly from the outer side to the inner side of the cell. This is the threshold potential. These terminologies are important to understand. Another important terminology is what is action potential and why is it called action potential. It is a wave of depolarization or electrical stimulation which consists of a stimulation wave or a depolarization wave and restoration of normal electrical balance across the cell membrane or a repolarization wave. So we can say that it is very important to understand that action potential consists of two processes, a depolarization process and a repolarization process. First there is a resting membrane potential, then a depolarization phase and then a repolarization phase. The mechanisms which are involved in the generation of cardiac depolarization and repolarization or action potential are very important. It is called action potential because it is in action, that is, it is an action or a flow or a wave of electrical current or depolarization and repolarization which continues across the cell membrane from one cell to the other in the cardiac muscle in a sequence or wave form. That is why it is known as action potential. You can see in this diagram, concentrate on it clearly, and you can see that there are, as I mentioned you, there are voltage gated sodium channel, calcium and potassium channel. In this cardiac muscle cell I have made only sodium channels. Let us suppose that we electrically stimulate this cell with adequate electrical stimulus. We stimulate this cardiac myocyte with an adequate electrical stimulus or appropriate stimulation. This results in inward movement of small amount of positive charges in the form of sodium and calcium ions. What happens is that this inward movement of some of these small ions of calcium or sodium inside the cell, it causes the electropositivity of cell to rise, that is, it is minus 90 millivolt, but when there is small influx of the positive charges, thus the resting membrane potential, which is minus 90 millivolt, will start rising towards more positive value until and unless it reaches that value which is known as threshold potential, which I have mentioned earlier. So when it reaches threshold potential, you see in another diagram that it was minus 90 millimole resting membrane potential, a small influx of cations occurred due to our electrical stimulation which was adequate and appropriate. So it started moving toward the more positive values. When the minus 70 millivolt or threshold potential reached, what happened at this level? When threshold potential is reached, there is opening of voltage gated sodium channels. So these voltage gated or voltage sensitive sodium channels open up when the threshold potential is reached, as a result of which there is rapid and massive inward movement or influx of sodium ions from outside into the inside of the cell, as a result of which cell will become electropositive by this electrical current of depolarization and will start losing its electronegativity on the inner side of the cell membrane. This event is known as depolarization. You can see here that these are voltage gated sodium channels This is sodium outer side. At voltage gated sodium channels open up when threshold potential is reached. There is a rapid influx or inward movement of the sodium ions into the cell. Depolarization, cell loses its electronegativity. You can see it was minus 90 millivolt, reached the threshold level minus 70, and then upstroke up to the plus 20. So the cell moves, the inside of the cell starts moving its electronegativity and starts moving toward the more positive value or a phase of depolarization. I have told you in this diagram that there was the rapid influx of sodium ions. After some time, we see that after this depolarization and sodium influx or inward movement of the sodium ions in the process of depolarization continues to reach more and more positive values when the voltage gated potassium and calcium channels also start opening. At this time, when sodium influx is continued, after some time the voltage gated calcium and sodium channels I had shown you previously, they also start opening up. You have, let us see the diagram again. These are the voltage gated calcium and potassium channels on the right side. So these channels also start opening up, as a result of which there is inward movement or influx of the calcium ions into the cell and outward movement or efflux of potassium ions out of the cell. So there is the movement of calcium from outward to the inner side of the cell, influx, and movement of potassium from inside to the outside of the cell or efflux. So calcium influx and potassium efflux takes place when these calcium and voltage gated potassium and calcium channels open up. So we can see that at this point that cations are being lost from the cell in the form of potassium and cations are being gained by the cell in the form of calcium ions. So there is no net change in the electrical potential difference of electrical potential across the cell membrane. That is, we can say that the potential is balanced by the cation influx and potassium efflux. Again, here you can see that these are calcium ions moving from outer side to the inner side, and these are potassium ions moving from inner side to the outer side. So calcium influx and potassium efflux balances the potential, so there is no net change in the potential of the cell. As I mentioned, you can see first there was resting membrane potential, then there is small influx of positive ions. You can see that it moves toward more positive value, less negative values, and at the level of threshold potential, voltage gated sodium channels opened up, resulting in massive influx or inward movement of sodium ions, keep reaching it, taking it to the positive values. Then calcium channels and voltage gated potassium channels, both voltage gated calcium and potassium channels also opened up, which resulted in calcium influx or inward movement and potassium efflux and outward movement with no net change in potential. This dotted line is for calcium and clear black line is blue line is for potassium. So there is no net change in potential. That is why we see this plateau or no change in the electrical activity in the cardiac action potential, which is a unique feature of cardiac action potential. It is not seen in other action potentials of cardiac muscle smooth muscle cell. So its plateau phase is the unique feature of cardiac action potential. Now we see that as the time passes and the wave of depolarization or electropositivity is nearing zero, calcium channels start closing, while potassium channels become more and more leaky and active. That is, they start opening in more and more number, then more and more potassium ions start moving out of the cell with higher number. So calcium channels start closing, calcium influx stops, while potassium leakiness continues and more potassium ions move out of the cell. There is more and more rapid efflux or outward movement of the potassium and out of the cell, that is, which results in a net loss of cations or potassium from the cell, as a result of which we see that cell starts losing its electropositivity, so that more and more positive charges are being lost and cell is becoming more and more electronegative and regaining its polarity with electronegativity on the inner side. This potassium efflux or outward movement continues. It continues so that a time reaches when the efflux reaches its maximum level, and until and unless it continues potassium efflux until and unless the potential is restored to the resting level once again from where we started. We can see that this process of continued potassium efflux or outward movement, which restores the potential of the cardiac muscle cell or cardiac myocyte to its resting level, is known as to the resting membrane potential level is known as repolarization. That is, the polarity of the cell has been restored to normal resting level of -90 millivolt or resting membrane potential. Cardiac action potential consists of both depolarization and repolarization. Let us concentrate on this diagram. Another important point you should know that in heart there is a cardiac muscle tissue, cardiac myocytes, and conduction tissue, SA node and AV node. We should know very clearly that in this cardiac action potential, cardiac myocyte, I have told you that sodium ions are the main ions responsible for the depolarization, but always remember the depolarization of cardiac pacemakers, that is the SA node and AV node, is not dependent on sodium, but it is dependent on calcium. This is a brief diagram of the cardiac action potential, very beautifully explained. You can see, as I told you, that potassium is the major intracellular ion, sodium is the major extracellular ion. Cell is electronegative on the inner side and electropositive on the outer side. -90 millivolt is the resting membrane potential. The neutrality is maintained by the sodium potassium pump. So, when appropriately or adequately stimulated, the cell becomes activated, the resting membrane potential starts running towards less negative values at the level of threshold potential -70 millivolt. The voltage gated sodium channels open up and there is rapid influx or inward movement of sodium into the cell. This is known as phase 0. It takes it up to +20 millivolt. This is phase 0. Then after some time, calcium channels, voltage gated calcium channels open up. There is a calcium influx. This is phase 1. And potassium efflux or potassium outward movement, that is inward movement of calcium phase 1, outward movement of potassium phase 2. After some times of this process, after phase 2, the calcium channels start closing while potassium channels keep open, and they start opening in more and more numbers, as a result of which more and more concentration of potassium ions move out of the cell. So the potassium efflux continues to such an extent that the cell starts losing its electropositivity and it's regaining its electronegativity. Potassium efflux continues in phase 3 and it reaches its maximum level to the point at which the cell regains its electronegativity to the level of resting membrane potential from where we started, that is phase 4. This is all about cardiac action potential. You can see this diagram. This is very important, and you should know that these are the concepts underlying the cardiac action potential. This is very important diagram. If you understand it, you will be able to understand what is going on in the cardiac pharmacology, how the drugs on the heart act and how the antiarrhythmic drugs act. Now let us briefly summarize it in Urdu. मैंने आपको बताया कि हार्ट के जो मसल सेल जो हैं उनकी जो कार्डिक एक्शन पोटेंशियल है वो डिफरेंट होती है. डायग्राम से मैंने आपको बताया कि कार्डिक मायोसाइट जो हैं ये एक दूसरे के साथ जुड़े होते हैं ख़ास किस्म के अरेंजमेंट से, जिसको हम सिंथिटियल अरेंजमेंट बोलते हैं. सिंथिटियल अरेंजमेंट का मतलब ये है कि सेल जो हैं, एक सेल का मार्जिन दूसरे सेल के साथ जुड़ा हुआ है और दोनों सेल्स जो जुड़े हुए हैं उनके दरमियान छोटी छोटी ओपनिंग्स हैं और सुराख है जिनके ज़रिए से एक सेल में से आयन्स या इलेक्ट्रिक करंट दूसरे सेल में जा सकती है. यही वजह है कि जब एक सेल स्टिमुलेट होता है तो सारे का सारा मायोकार्डियम स्टिमुलेट होता है और इस वजह से कार्डिक मसल जो है इट कंट्रैक्ट एज वन यूनिट, एक यूनिट के तौर पे कॉन्ट्रैक्ट करता है. आप इसको देखेंगे तो ये एक यूनिट के तौर पे कॉन्ट्रैक्ट करेगा. इट कैन बी वेंट्रिकल, इट कैन बी एट्रियम, बट इट कॉन्ट्रैक्ट्स एज वन यूनिट. इसी तरह मैंने आपको बताया कि रेस्टिंग मेम्ब्रेन पोटेंशियल होती है अंडर फिजियोलॉजिकल कंडीशन. सेल जो है इनर साइड पे इलेक्ट्रोनेगेटिव है, आउटर साइड पे इलेक्ट्रोपॉजिटिव है. जब हम इसको एडिक्वेटली स्टिमुलेट करते हैं, थोड़ा सा हमने आपको बताया कि इसमें सोडियम इनफ्लक्स हुआ, उसकी वजह से जो इसकी रेस्टिंग मेम्ब्रेन पोटेंशियल थी वो राइज करना शुरू की और ये फिर थ्रेशोल्ड पोटेंशियल के लेवल पे आई. जब थ्रेशोल्ड पोटेंशियल के लेवल पे आई तो उसके बाद जो वोल्टेज गेटेड सोडियम चैनल थे वो मैंने आपको बताया, वोल्टेज गेटेड सोडियम चैनल ओपन हो गए तो लार्ज नंबर ऑफ सोडियम आयन जो थे सेल के अंदर आ गए, जिसकी वजह से ये इसकी एक्शन पोटेंशियल की जो स्पाइक है ये ऊपर 20 मिलीवोल्ट तक चली गई. उसके बाद हम फर्दर देखते हैं कि जैसे ही सोडियम इनफ्लक्स हुआ उसके बाद हमें थोड़े अरसे बाद सोडियम इनफ्लक्स के बाद जब सोडियम अंदर जाना शुरू हुआ तो कुछ अरसा सोडियम के अंदर जाने के बाद हमने देखा कि कैल्शियम चैनल जो थे वोल्टेज गेटेड वो भी और पोटेशियम चैनल वोल्टेज गेटेड वो भी खुल गए और कैल्शियम सेल के अंदर जाने लगा, पोटेशियम सेल से बाहर आने लगा. चूँकि बाहर जाने वाले चार्जेस भी पॉजिटिव थे पोटेशियम और अंदर आने वाले चार्जेस कैल्शियम पॉजिटिव चार्जेज जो थे वही अंदर आ रहे थे और पॉजिटिव चार्जेज बाहर जा रहे थे। सो कैल्शियम इनफ्लक्स था, पोटेशियम इफ्लक्स था। इस वजह से नेट चेंज कोई नहीं आई और ये प्लेटू आपको नज़र आएगा सिर्फ कार्डियक एक्शन पोटेंशियल में। ये आपको स्केलेटल मसल पोटेंशियल में नज़र, एक्शन पोटेंशियल में नज़र नहीं आएगा। ये इंपॉर्टेंट पॉइंट है, इसको याद रखिए। इस फेस के अंदर फिर एक टाइम ऐसा आता है कि कैल्शियम चैनल जो है वो क्लोज हो जाते हैं, जबकि पोटेशियम चैनल जो हैं वो चलते रहते हैं, वो ओपन रहते हैं और पोटेशियम सेल से लीक होता रहता है। यहाँ पर देख लेते हैं पोटेशियम चैनल जो है, पोटेशियम का इफ्लक्स इसने बताया हुआ है, ये जारी रहता है और यहाँ तक कि ये सेल जो है अपनी इलेक्ट्रोनेगेटिविटी रीगेन करता है। इलेक्ट्रो पॉजिटिविटी ख़त्म हो जाती है, इलेक्ट्रोनेगेटिविटी क्योंकि पॉजिटिव चार्ज लॉस हो रहे हैं, उस वक्त तक पोटेशियम इफ्लक्स होता है जब तक रेस्टिंग मेम्ब्रेन पोटेंशियल रीस्टोर ना हो जाए। इसको एक दफ़ा फिर देख लेते हैं। ये पोटेशियम जो है मेजर इंट्रासेलुलर आयन है, सोडियम मेजर एक्स्ट्रासेलुलर आयन है। ये रेस्टिंग मेम्ब्रेन पोटेंशियल -90 मिलीवोल्ट थी, थोड़ी सी स्टिमुलेशन दी इसको, थ्रेशोल्ड पोटेंशियल आई तो वोल्टेज गेटेड सोडियम चैनल्स ओपन हो गए, बहुत सा सोडियम सेल के अंदर गया और ये फेज 0 जो है ये इसमें नज़र आ रही है। ये एक्शन पोटेंशियल की 20 मिलीवोल्ट तक उसको ले गई। फिर थोड़ी देर बाद कैल्शियम, वोल्टेज गेटेड कैल्शियम और वोल्टेज गेटेड पोटेशियम चैनल्स ओपन हो गए। कैल्शियम सेल के अंदर आने लगा फेज़ 1 और पोटेशियम सेल के बाहर जाने लगा फेज़ 2। थोड़ी देर बाद कैल्शियम चैनल जो थे वोल्टेज गेटेड वो क्लोज हो गए, कैल्शियम अंदर आना बंद हो गया, जबकि पोटेशियम का इफ्लक्स या पोटेशियम का बाहर की तरफ निकलना सेल थे वो जारी रहा। पोटेशियम चैनल ना सिर्फ ज़्यादा ओपन हो गए, उनका नंबर भी बढ़ गया और ज़्यादा पोटेशियम बाहर जाने लगा, जिसकी वजह से पोटेशियम इफ्लक्स चलता रहा। उस वक्त तक पोटेशियम इफ्लक्स या पोटेशियम की आउटवर्ड मूवमेंट सेल से जारी रही जब तक पूरी तरह सेल ने अपनी रेस्टिंग इलेक्ट्रोनेगेटिविटी रीगेन नहीं कर ली और फेज़ 4 के अंदर रेस्टिंग मेम्ब्रेन पोटेंशियल जहाँ से हमने स्टार्ट किया था वो रीगेन नहीं होगी। तो आज के लिए इतना ही। देन नेक्स्ट टाइम वी विल डिस्कस विद यू इंशाल्लाह अबाउट दी different topics. I will come with different topics and I will continue inshallah with these lectures, and I will not take break. I was busy with some professional engagements, therefore could not come. So I will try to teach you cardiac cycle and electrocardiography and ECGs and cardiac arrhythmias inshallah. Thank you very much.